Hi there. GKE Autopilot is a fully managed Kubernetes cluster solution from Google, released last week, that brings together all the best features in scaling, security, data operations the Google way. And the key to this new product is that you only pay for the pods that you use, and the billing is based on the total of vCPUs, memory and storage requested. But hang on, was the old Google Kubernetes engine not fully managed already? Well, GKE was indeed a very hands-off Kubernetes cluster. With the standard GKE cluster, you don't have to worry about the control planes, as these are managed by Google. You also don't have to worry about setting up storage providers or even networking. You don't need to set up load balancers, as these are created on demand based on your ingresses, with the secure cluster authentication switched on by default, with the ability of scaling the number of nodes in a cluster using the GKE cluster autoscaler. Then you have automatic upgrades using release channels and so on. So what is GKE Autopilot adding? With GKE Autopilot, you no longer need to worry about the cluster nodes and what CPU and memory each node requires. Also, since you no longer need to worry about nodes, there's no need to guess how many nodes you need to run your workloads. And with that, you no longer need to guess how big your cluster nodes should be. With GKE Autopilot, all you need to worry about is to have a little bit more discipline in detailing the workloads that will run in the Kubernetes cluster. This means that it is quite important for your Kubernetes resources YAML to have an accurate figure for how much vCPU and memory each container requires. No more, no less. More on that later. With this in mind, instead of being charged a cost per node, you get charged a cost based on the total amount of CPU cores and memory that you use, and any ephemeral storage that you request. The key here is request. For example, see this resource request for a WordPress pod. In this YAML definition, we request for 1/10 of a CPU core and 128 megabytes of memory to be allocated to the WordPress container. What you actually pay for with the GKE Autopilot is the requested resources. Just to have an idea of how much it would cost using GKE Autopilot, I did a completely random simulation for the cost of a workload. Basically, it's a month of CPU usage, a full month, which is about 730 vCPU hours, and about 891 memory hours for a single pod. That requests a whole CPU core to itself. You end up paying at least $39.99 per month. Note that this value is just an estimation and definitely varies across different GCP regions. Now we need to also mention the management fee. There is a 10 cents per hour management fee for the cluster. If you only have one GKE Autopilot cluster and it's zonal across all your projects, for a single billing account, you receive a credit of $74, which covers for the total of the management fee if you only have one cluster. That means you have zero management fee in that case. But note the important exception there, where if you prefer to use a regional cluster, and you probably should use a regional cluster instead of a zonal cluster, in that case you don't get the discount. It's a little bit sad, but it's understandable, as it will cost more to Google in order to keep your workloads distributed across all the zones in a region. Google thinks that for most customers, the big ones, they will definitely save money, because most of us are incredibly bad at estimating the correct amount of nodes and any resources needed to run a production workload. I think I agree with that. GKE Autopilot does have plenty of restrictions, so let's just briefly discuss some of the key ones that caught my attention. You can actually see an exhaustive list in the link that I put in the description. First of all, you're not able to modify the kube system namespace anymore. Therefore, you will be prevented from adding new storage providers or do any changes related to networking. Also, you're not going to be able to have any more privileged pods. This means that you can't mount Google Cloud Storage buckets with GCS views anymore. Ouch, that hurts. Since you don't have to worry about how many nodes you need to run, you no longer have access to modify anything to do with the nodes. You can actually see the nodes with kubectl, but you can't touch them. Since you can't control how many nodes your cluster has or when and how they run it, it is only natural that you no longer should be able to control node affinity for your pods. Instead, you should rely on pod affinity if you really want 2 or more pods to run next to each other. You are also limited from using many storage classes available in Kubernetes, as they would require access privilege to the nodes, which we don't have. The next restriction is basically there to make it easier for Google to bill us better. With the GKE Autopilot, we basically lose the ability of setting a resource limit higher than the requested CPU and memory resources. So you need to ensure that you give from the start enough resources to your pod. No less, no more. And you might have noticed in the example YAML that we saw before that the requested resources, CPU and memory, are actually the same as the upper limit of resources. This was not a mistake, as you know now, and what will happen if you try to set a higher limit? Basically, a GKE Autopilot will just override the limit and make it equal to the requested value. Now, the next restriction is to do with security. With the GKE Autopilot, you will have to use workload identity and shielded GKE nodes. And there's really no choice. Shielded GKE nodes are great, not much to say about that. Who really wants a potential attacker to pretend they are a node in our cluster? However, being forced to use workload identity, I know it's more secure, but it also means that configuring access to GCP resources, which we have to do by using service accounts, is going to be a lot more complicated and involved. It means that the only granularity we have is at the namespace level. All right, that's all for now. If you found this video informative, don't forget to press the like button and don't hesitate to subscribe. And see you again soon. Happy coding!